So this reading, so I'm going to read over here. Reading, so 15, 16, 17, 18, 19. So this is 17.5. Usually when you have an equipment like this, you can read to the nearest half smallest division. Okay, so half smallest division is 1, so half of it, so 0.5. I can read it. I will not attempt to say that this is 17.6 because this is beyond to what I can estimate. So I can just estimate half the smallest division, not more, not less. So even if it would have been so 15, okay, let's say the measurement would have been like this, then I would say that it is 17. I will not go to say that it is 17.2, for example. I cannot say that. I can only estimate half the smallest division. So if I see here, this is closest to the 17 mark, so 15, 16, 17, closest to 17, so I'll say that it's 17. In this case, it's 17.5, and uncertainty here is half the smallest division, so smallest division is 1. So 15, 16, 17, 18, 19, 20. So smallest division is 1. Therefore, half of it would be 0.5. So 0.5. Reading with uncertainty, 17.5 plus minus 0.5. So this is to 1 dp, this is to 1 dp, so it's correct. The second example, here again, so let's say 1.1, 1.2, 1.3, 1.5, 1.6, 1.7. So this is 1.7, and you can see here if you draw a line close, so this is here, so it's closer to 1.8. okay, closer to 1.8, so not 1.7, so that would be, the reading would be 1.75. okay. The uncertainty, so the smallest division here, so what I can measure here, so 1.1 minus 1, that's going to give me 0.1. Half the smallest division of this will give me 0.05, so 0.05, reading with uncertainty. Okay, 2 dp here, 2 dp here as well. Okay. Length of the wooden stick. So I have 4.5 is here. 4.5 is here. That would be, so the next one is 4.6. So I can say it's 4.55. Okay, now when I'm measuring, the smallest reading is 0.1, because that's 4.1, 4.2, etc. Divided by 2, half of it, so 0.05. Now, normally I would say that the length is 4.55 plus minus 0.05. This is what I would say normally, but we have these options here. So this one definitely it's going to be eliminated because the smallest reading is 0.1 divided by 2, 0.05. This is too accurate because this is 3 dp, way too accurate. And this one, the second one, you see 0.54. You can't say that it's 4.54. This is wrong because it's either 4.50 or 4.55 or 4.60. That's it. It can't be, you can't have in between numbers here. Okay, so this one is eliminated, so I'm left with this one. Okay, this is well written. It might not be the one that is read the best. Maybe there has been some form of parallax error here, but it's the one that is quoted in the best way. So this is the right answer, the first option. Now, one thing I would like to specify is that uncertainty values, if you look at all the uncertainty values, they are always to 1SF. All uncertainty values should always be to 1SF. You can never have uncertainty to be equal to plus minus 0.551. This can never happen. Even if you calculate it, you get it like this. All uncertainty should always be to 1SF. Okay, whatever the number of dp, the dp can be different, but the SF uncertainty is always quoted to 1SF. Just keep that in mind. 1SF for uncertainty. It could be 0.0005. This is still okay. Whatever the number of dp, like I said, doesn't matter, but it should be to 1SF. Okay, so let's move on to the next part now in the next video.